Okay, guys, here we go. I have three examples here to pick up where I left off. There is going to be some work at the end of this one, but I broke it down. Example one, we're going to find the x-intercepts of this, and I want you to know that 0 can happen at any time. What do I mean by that? Well, let's investigate. First off, I would set this equal to 0. That's what I would do. So it looks like an equation. Set equal to 0. Then what I would do is I would think, what are my possible shelf numbers for this problem? Now 24's got a lot of factors. So if I was going to write this out, plus or minus 1 goes into it, 2, 3, 4, 6, 8, oh my gosh, 12. What a jerk this number is. A lot of stuff goes into 24. So if I wanted to do this, well, I've got to, well, lucky for me, it's all in the right order. So I just take down my numbers. 1, there's a 2, there's a negative 12, there's a negative 24. I am going to bring down the first number, which, by the way, is still a 1. It's still a 1. Now, what goes in the shelf? So here we go. We're going to grab the graphing calculator. Now, today, just so you see the difference, my mode, I'm going to set it to math print. And real subtle, but there's something that you have to know about. So here we go. I'm going to quit that screen. I'm going to go second mode. So that's quitting. Oh, there it is. Quit the screen. And I'm going to go to y equals, and I'm going to enter in my function. So here we go. I want to enter in x to the third. So I'm going to still use the x button. I'm going to still use my power key, the caret key here, but then you'll see it goes up as an exponent. So x to the third. But if I try to do plus the next number, it'll stay up in the exponent. I don't want that. So I have to know what to do here. So x to the third, what I do is I use the side arrow and it drops it down. Then I can continue. So x to the third plus 2x to the second. Then I side arrow to get it to jump down again. Minus 12x. And then what is it? Minus 24. And I have everything entered in. Please pause it if you have to. Double check. Make sure you and I have the same graph. And I'm going to hit graph. Here we go. Now, if your screen does not look like mine, make sure you have Zoom Standard. That might be one of your issues. So here we go. It appears to me that this number right here is between 3 and 4. Well, if it's a number between 3 and 4, oh, down here it looks like it's between negative 3 and negative 4. But, heck, those aren't in my possible list of numbers. The only one that looks good to me is negative 2. So I'm going to say second, calculate the value at negative 2. And what do I get? I do get that that's a 0. So I say, okay, I'm going to put the calculator aside for now and just crank out the algebra. So I'm going to just turn this off myself so it's out of my way. And I go back and I say, you know what? Looks like negative 2 was the choice to use from my rational roots. Here we go. Negative 2 times 1. I go like that, and then I get a 0. And I go, whoa. See, 0 can happen at any time. And sometimes people think they're doing it wrong because they are trying to get a 0 over here. They go, what do I do? Well, 0 is a number. Don't worry about it. If 0 didn't exist, I wouldn't know how much money I have. I wouldn't know how many friends I have. So I need 0 in my life. Anyway, negative 2 times 1, I got that. There's my 0. Negative 2 times 0 is 0. That's okay. Add down. We still continue. And then negative 2 times, there it is. See? Ha ha ha. So it can happen anytime you can get a 0. You just want to make sure the last thing that comes out is also a 0. So let's continue. This we haven't seen before, but this would be an x squared plus the ox. I call it 0x's. I call that the ox. Minus 12 equals 0. Hey, this turns out to be an equation that looks like this, which I refer to as a cheerleader equation. I call these cheerleading equations. Why? Because I can take this and set it equal, whoop, I banged into that. I can set it equal to 12. An equation like this is, I call them cheerleaders because I want to get the squared term alone. And if I move the 12 over, then I can root like a cheerleader does. However, technically they are called incomplete quadratic equations. In our book, it would be referred to as an incomplete quadratic equation. It would not say cheerlead equation in our book. But let's continue. Hey, right here, when I take the square root of x squared, I get x. What's it equal? Plus or minus, let's break this up, that's 4 times 3, so I get 2 rad 3. So my answers are, one of them's there, x equals negative 2, and then plus or minus 2 rad 3. There's my 3 answers to that problem. Why did I create this example for you? Because I wanted you to know that 0 can happen at any time. Now, here's my next example. I got 2 more. I haven't shown you something called Zoom Box. I am about to show you something called Zoom Box. It's a really good trick to know on your calculator. And if you haven't noticed, as we go along, I try to show you a little bit at a time different things you can do with your calculator. But here we go. I am going to use synthetic division for this problem. So I would say, what are my possible shelf numbers? 1 goes into 27, 3, 9, 27. Those are my choices. Now, I would technically do what? I would set this poly equal to 0, I would, to solve for my x-intercepts. Now, there are different terms for x-intercepts. I just want to mention this because it's going to happen sometimes, and these are synonyms. They sometimes call them x-intercepts. Sometimes you'll see them written in the book. It'll say find the roots. Sometimes it will say calculate the zeros. In fact, on your calculator, let me show you this. Second trace. So I'm going to the calculate menu. Look, there's a thing here that says 0. We're not going to worry about it right now. We don't need that, but it is there. So anyway, I'm going to get rid of this. Second quit. So here we go. I'm going to be doing some synthetic division. So I need a 1, a negative 9, a 27, and a negative 27. I am going to draw this line. I'm going to bring down the first number. Got to pick a shelf number. So here we go. Whoops. Can't see that. But here we go. I'm going to graph it now. So it's time to go y equals. And I'm going to get rid of the thing that was already there. So I'm going to enter in my new problem, which is x to the third. Remember, I'm in math print mode, so I'm going to have to go side arrow. Minus 9x to the second, side arrow, plus 27x, side arrow, I almost forgot that, whoop, minus 27. So I hit graph, and I take a look at this, and I say, what's happening there? What is that all about? Seems like there's a lot of noise going on right here. So if I want to get a little bit closer in on the action and see what's going on, I can do something called Zoom Box. Let me show you how this works. In the middle, there's something that says Zoom. If I hit Zoom, I can draw a box. I'm going to hit Enter to enter this function. Zoom Box, I'm going to hit Enter on my key. You can't see that, it's off camera, but I just hit the Enter button. You'll see I have a blinking cursor. What I'm going to do now is I'm going to use my sideways arrows, and I'm going to move this little blinky guy over here a little bit, and I'm going to go up a little bit, because what I'm trying to do is I'm trying to make a box. That is going to be the top corner. Once I get the cursor where I like it, I hit enter, and you'll notice it turns into a square. Now I'm going to stretch that square out. Look, I'm just holding down the arrow key. I'm going to stretch it down here. See that box? Guess what? You can draw a box any size you want. You can start it wherever you want. But once you draw a box, if you hit enter on the key, it'll take you inside that box. And what you will see is the only thing that's happening on your screen is that little box. And in fact, when I am inside of a box, I can do it again. I could box inside a box. I'm not going to do it right now. But here's the thing with this. I now think that this is a twist. I personally believe that this thing right here, where it intersects the x-axis, is at, where's my list? Is it 3? I can do second calculate the value at 3. I'm going to see what happens. And it says what? Oh, it says 0. Now, what does that mean? It means I have a starting location for my synthetic division. I do. So I'm going to get this out of my way for a second, and I go, okay. I'm going to move you out of the way and say 3 is the shelf number I will choose. 1 times 3, 3. Add down, I get what? -6, it looks like. 3 times -6, I get -18. That's going to give me a 9. 3 times 9, I'm going to get 27. Hey, that is what I was supposed to find. So I know one of my answers is 3. But let's see if my hunch is correct here. I am going to write this quadratic, and I'm not going to jump on the quadratic formula right now. No way. Because I noticed this guy is what we call a perfect square trinomial. That's a perfect square. What times itself is x squared? X. The last sign is positive. So that means to get this, it would either be a positive times a positive to be a positive 9, or a negative times a negative. It's 2 negatives. What times itself is 9? That's 3. This thing is called a perfect square trinomial. Verify it with me. You can see that that is how that factors. And remember, we're setting this equal to 0. So this answer here is a 3. This answer here is a 3. You're getting a 3. You're getting a 3. Everyone's getting a 3. I feel like Oprah. But what does that mean? It means when I look at this graph. Now watch out. What? Zoom standard. Don't forget, you zoom boxed. Your calculator is in a box. So I always tell people, before you start the next problem, you should probably zoom standard. And I got some kind of weird glare on this screen. I'm sorry, guys. I don't know why it's doing that. Here, I'm going to pull it closer. See this here? That's a twist. When we did our very first lesson in graphing parent functions, this guy is what a twist looks like on your calculator, which means, hey, this happens 3 times. So your answer is x equals 3. You don't have to write it down 3 times for me. If x equals 3 is the only value that works, that's okay. But on the answer key, you'll notice I wrote the word triple so that you understand, hey, that's all you're going to get. It's just a multiple root. Now, technically, these are called triple roots. That's why I call them triples when I teach people how to graph them. It's called a triple root, or a fancy way to say it, so you sound real smart, is a root of multiplicity 3. I don't care if you want to sound smart, you can do that. I don't ever say root of multiplicity 3, really. But that was my second example. What did I want you to get from that second example? I want you to know how to zoom box. And I want you to know what it looks like when you have multiple roots. In this case, it was a triple. All right, let's do our last example. And in this last example, I'm going to zoom box again. So, whoops, here we go, sorry. Example 3. Multiple zoom boxing. All right, so this is what I want you to get from this. First things first, it's in the right order. Everything's legit. I'm going to set it equal to 0 because technically that is what I'm supposed to do. I see that it's all ready for me to do synthetic division, but what are my possible roots in this one? My possible roots would be 1 goes into 20, 2 goes into 20, 4, 5, 10, and 20. There we go. And I'm going to do synthetic division twice, it looks like, because I have a 4th power problem. So let's get that ready to go. I'm going to do, what is it? 1, -4, -1, 20, and -20. I'm going to draw a line. I'm going to bring it down. I'm going to use a shelf. And what shelf number should I pick? I don't know, so that's when I grab my calculator and I hit y equals. I'm going to clear the last one out. I'm going to get rid of it, and I'm going to enter in x to the 4th side arrow minus 4x to the 3rd side arrow minus x to the 2nd side arrow plus 20x minus 20. And I have everything entered in. Make sure you got it right. If your graph doesn't match mine, that's why. Hit graph. Let's see what it looks like. Ooh, I got another twist. Or do I? Maybe I'm just being evil. And I am, just so you know, I'm being evil. That's not a twist. It's not. But it looks like a twist. It sure does. But you know what I'm going to do? I'm going to show you that, well, you know what? Hey, looks like it crosses at 2. I'm going to do that first. Let's go. Second, calculate the value at 2. Sure enough, I have a 0. I have a 0. I have a root. I have an x-intercept at 2. I'm using the synonyms. So I'm going to start my synthetic division right now. I'm going to move my calc out of the way and do 1 times 2. I get -2. Boom, boom. -4. That looks like a -5. 2 times that is -10. That looks like a +10. 2 times that is 20. Boom, I got it. Yeah. So x equals 2 is one of my answers. In fact, according to this, it looks like it might be the same answer 3 times. Let's take a look at what's happening there, though. I'm going to zoom box again. So let's practice the zoom box. Zoom box. So I hit enter, or I could hit the number 1 on my keypad. Whatever's highlighted, that'll do it. I am going to move my blinky guy, my cursor, over to the side a little. And I'm going to, just so you can see this, I'm going to put my top corner of my box right there. I'm going to hit enter. It turns into a square. I'm going to stretch the square sideways. I'm going to stretch it down. Maybe back it up a little. I don't know. I just want to get that little spot right there and take a look at it. Look. Ooh, so wait. Now look. It sure does look like it twists right there. It does. But if it were to twist right there, I would have this number work twice. I would have this number occur twice. Or sorry, 3 times. I would have it occur 3 times. Why am I saying twice? So, you know what? I'm going to zoom box one more time. So I'm going to go zoom box. So I go zoom box because I want you to see this. Because sometimes graphs will totally fake you out. I'm going to just get really close on this thing. So I can box when I'm inside a box. Check this out. I just want to look at this spot right here. Enter. Once you have your box drawn, you enter. So there it is. Ooh, that's a 2. But do you see how it slightly goes under the x-axis and then goes up? Do you see that? Do you see how sneaky this one is? So what's really happening here is, and I'm just going to draw a subtle picture. Boom, boom. It's actually going like this. Doink, and then it's coming up here. It's got a bounce, not a twist. But man, that is so subtle. Look at how close that is. I could zoom box again and you get right up on it. But what does that tell me? It says, well, I'm going to go back down here and I'm going to use 2 again. I'm going to bring the 1 down. I'm going to go 2 times that. And then I go, uh-oh, there's a 0. Well, that happened to me in example 1. That's okay. 2 times 0 is 0. Add down, I get -5. 2 times that, -10. Boom. But wait, when I get this, that just means I got it down to second power. And I own it once I get it to second power. And there's the ox. When you see there are no x's, when you have no x's, it means you're going to solve it like, like this. I'm going to move the 5 to the other side. I'm getting the squared information by itself. And then I'm going to root like a cheerleader. Ready? Okay. Here we go. That's x equals plus or minus rad 5. So my answers are, let's go back up here. I have the answer 2. That's a double. You don't have to tell me that, but just in case you're confused, that's a double root. It happened twice. And then my other 2 answers are plus or minus rad 5. Now, roots always travel in pairs. When you get an answer that's a square root, its evil twin will always be there. So if you have positive rad 5 for an answer, you're going to get negative rad 5. So what does that count as? 1, 2, 3, 4 answers total. Now, be careful of this because people do this all the time. I want to check my answer to see if rad 5 is correct. Do yourself a favor. Don't leave yourself stuck inside of a box. Don't be in the box. Zoom standard. Zoom number 6 is standard. Zoom standard. Get out of that box. Because if you try to use this calculator again later and you forgot you were in a box, you're going to be in trouble. So here we go. I'm going to go second, calculate. Come on, second, calculate. I'm trying to do it while I'm holding it. Second, calculate the value at square root 5. You ready? Let's see what it says. It says 0. Because I am rad. It's rad 5, and I am rad also. Okay, guys, here we go. I wanted to show you those other added beautiful features of the calculator. Here we go. First things first. When I show you the answer key, I want you to follow this. No decimal answers. When you guys take the assessment for this, I will not accept decimal answers. If you have radicals in your answer, leave them in simplest radical form. Then, some of these x-intercepts can be found using the calculator tricks alone. You can solve some of these. If you're able to find all answers using the calculator, that's fine. List your answers and write, used my calc. Okay? I will give you credit for that. There are 3 questions like that in this assignment. Show work for the other questions. So on 7 of the questions, you're going to have to use all the synthetic division tricks, etc. But on 3 of these, if you know how to use the calculator well enough, based on what I've shown you, you can solve 3 of these questions. You can solve 3 of these questions just by using the calculator. So what does it say? It says, find the x-intercepts, leave any rads in simplest radical form. Yeah. So here's the first, 7 you can see, and then I'll scroll it down a little. Take a picture of it so you have it. Here's the next ones. Take a picture of it. Remember, you got to set them equal to 0 because they're written in equation form or function form. Then, last but not least, when you're doing these, please check your answers. I wrote it on a smaller sheet so it would fit on one screen. So, pause it, take a picture of it. There's your answers. Please check your work to make sure you're getting it right. Okie doke. Good luck. See you on the other side. Bye-bye.